Welcome to section 2.6. We're talking about rational functions today. We want to start by doing the intro. I would like you to put this first function into your graphing calculator. Please make sure that when you put it in your y equals that you put parentheses around the top and the bottom. We're then going to go to the table and look at some values. So if you'd like, pause this video a second, fill this in, and then you can double check with us. Once I put this in my graphing calculator, I'm going to start entering my y values. At -5, I get 2.25. At -3, I get 2.5. At -2, you get 3. At -1.5, you get 4. At -1, you end up getting an error. Okay, and we'll talk about that in a second. At -0.5, you get 0. At 0, you get 1. At 1, you get 1.5. And at 5, you get 1.83 repeating. And so what I want to do is plot these on the graph a second. Up 2.25. So you have a point right here at 3, about 2.5. At -2, up 3. 1.5 goes up to 4. At -1, you have an error, which means I'm never going to touch that. So what's going to happen is my graph is going to get really close to that, but never actually touch it. So I'm going to draw in this idea. In just a second, I'm going to asymptote. At 0.5, -0.5, you get 0. At 0, you get 1. 1 is 1.5. And at 5, you get about 1.83. And so this ends up, again, you can't touch the 1, but you end up getting something like this. And this is what your graph should show. Please be careful. Sometimes the 83s do throw this line in at -1. They should not. It's not an intentional line. Your calculator just doesn't know how to pick up a pencil. But basically, because I have this error here, I'm going to draw in a vertical asymptote. Okay? One thing I'm going to ask you to do is on your graphs, you must show your asymptotes, okay? If you want to keep all of the points, these asymptotes have to be in there because I need to make sure you don't touch them. There's also going to be an asymptote at +2, and I didn't obviously graph this right. Let's change this a moment. I will fix that. You're going to have an asymptote at 2. And so let me put my graph back in a moment. Let's try this again. At 1.5 and at 5 you get 1.83, and you end up getting something like this. I apologize for that. And so as we're kind of going through again, I want you to see this. We're going to classify general asymptotes in a second, and then we'll give you some rules as to how to just look at a graph or look at a function and actually tell me the asymptote. A vertical asymptote occurs at an x equals a number. In this case, our vertical asymptote is at x equals -1 because that's where my error occurs. And what happens at that asymptote, this says here as x goes to that value of a, this means from the left. Okay, so as I'm coming from the left, in this case, as I get closer to my asymptote from the left, my graph is going to go up to +infinity. However, you will have graphs where it ends up going to -infinity. And so I'm going to put both here. But for our graph, when we go to the left and I get close to that value, you'll see it goes up to infinity. This second one says, as I approach that asymptote from the right. Well, let's look at our graph. As I'm coming from the right, our graph is going down. And the way we say down is f of x approaches -infinity. But again, keep in mind, some of the graphs could go to +infinity, so I want that included as well. Okay. The second part is the horizontal asymptote, and that's that line we drew in here at y equals 2. It's always a y equals equation, and this always describes the end behavior, and I have it in bold because there is an example coming up. It doesn't describe what happens in the middle of the graph, it describes what happens at the ends. So when x goes to -infinity, so as I take my x values and let me go negative, as I go negative, it's getting closer and closer and closer to that value of b. And as I come from the positive side, the same thing, f of x gets closer and closer to b. And so you're looking, as I go to the left, I get close to that asymptote line. As I go to the right, I get closer to that asymptote line. And so this is the idea, and I think truthfully, I'm going to go elementary here for a little bit. I think the idea, though, of tracing your graph with your finger is truthfully one of the better ways to do this. So what we're going to do is go to our graphing calculators, and we're going to look at where we find vertical asymptotes. And vertical asymptotes are where you have errors. So if you'd stick this function in your calculator, I'd stick a parentheses here and then one extra parentheses around the bottom. The question then becomes, where do you have errors? And I think you could probably look at this and said, when will you have an undefined fraction? We'd have an undefined fraction when our denominator is equal to 0. So I have vertical asymptotes at x equals -5 and at x equals +2. Okay, and again, the idea is when you get an undefined fraction is when you have these vertical asymptotes. So in general, the vertical asymptotes occur at x values where there are zeros in the denominator, or you could say it where f of x is undefined. They really mean the same thing, but I want both wording there with you because, again, you're looking at two different things. You're really looking at zeros of the denominator, which make your fraction undefined. So it kind of does the same thing, but again, I'm giving you both wording. Horizontal asymptotes are the ones where you have a few rules, and so you'll want to look at the rules as we kind of go along. We talked about these in Algebra 2, but I just want to kind of clarify. And we're talking about degrees. When the degree of the numerator we call n, the degree of the denominator, we look at this too. I'm sorry, the degree of the numerator is a, the degree of the denominator is b. So if the degree of the numerator is less than the degree of the denominator, then you only have one horizontal asymptote, and that occurs at y equals 0. And we're going to look at some of these as well. If the degree on top is the same as the degree on bottom, then in order to find the asymptote, what we're going to do is we're going to say a sub n over b sub n. Let me erase that one and just try over. Okay, and here's basically what it means. A sub n is the leading coefficient of n of x, so of the numerator, and b sub n is the leading coefficient of the denominator. And so basically what it says, if the degree is the same on top and bottom, then you divide their leading coefficients. Okay? The last type, if the degree on top is bigger than the degree on bottom, then you don't have any. There are no horizontal asymptotes. And I'm going to expand on this in a sec later on, but this is the first idea. So we're going to find both vertical and horizontal of this function here. You will want to put this in your calculator. Again, this is a lot of calculator stuff, but again, if you remember the rules, maybe you won't need it. Okay, so let's start with the vertical asymptotes. I always start with vertical because then I just look at the denominator. My goal is, when is this denominator going to be equal to 0? Okay, well, I take a look at this. I can factor it because 4 times 2 would get me 8, and it would also add to 6. And so my denominator can be factored as x plus 4 and then x plus 2. And if I set this equal to 0, my vertical asymptotes occur at x equals -4 and at x equals -2. And if you go to your calculators and you look at your table, these are places where you should see some errors in your table. okay? The horizontal asymptote, we look at degree. The degree on the top in the numerator is less than the degree of the denominator. So I go back up to my rule. If the degree is less, then I have an asymptote at y equals 0. And this is something, though, that you should be able to see, too, from your graph. I go more by the rules than I go by the graph, but it's up to you if you want to memorize them or not. So this is the first example. We're going to do a couple more. Here's another one. Take a look. Can we find vertical and horizontal? Again, I'm always going to start with the vertical ones. And I'm going to set my denominator, x squared plus x minus 6 equal to 0. Again, I'm going to ask myself, can I factor? And truthfully, for this lesson, you're probably going to be able to factor them all. While 6 is 3 and 2, in order for it to be a positive 1, the 2 would have to be negative. So I have an x plus 3 and an x minus 2 in factored form, which tells me my two asymptotes are at negative 3 and positive 2. You need these equations. X equals, because it's a vertical line, x equals negative 3 and x equals positive 2. When you do your horizontal asymptotes, we go back to the rules on front. When the degree is the same in the numerator and the denominator, then what we do is we divide the leading coefficients. So 2 divided by 1 equals 2. So my horizontal asymptote occurs at y equals 2. Okay? We're going to help you with graphing these. So these rational functions we are going to graph. So as we go through and look, we do give you a set of guidelines to follow. This will help you kind of get the maximum points on your graph. It's really going to look at that the easiest. And so here's what we're going to do. We're going to simplify this if possible. What I'm going to do is factor this denominator. So x over x minus 2 and an x plus 1. This doesn't necessarily help us simplify because there's no factors to cancel on top and bottom, but at least this will help me later for my vertical asymptotes. Okay, we're going to do number 2. So this is number 1. Number 2, we're going to find the y-intercept. So we're going to set x equal to 0. In order to find the y-intercept, okay, I'm going to put zeros in for my x's. So 0 over 0 minus 2 times 0 plus 1. Well, let's be honest. 0 divided by anything is always 0. So what that says is I have a y-intercept of 0, 0. It's going to hit my y-axis there at 0, 0. The number 3 is to find the x-intercept. And so I'm going to set my fraction equal to 0. Now let's be honest. How do I get a fraction to equal 0? When the numerator equals 0. So when my numerator equals 0, my fraction will be 0. Therefore, look at it, it's the same intercept. It's at the origin. Okay, so I found both my x and my y-intercepts. Number 4, we're going to talk about asymptotes. We're going to talk about vertical asymptotes. We've already factored my denominator. So let's look at my denominator and say, well, my two vertical asymptotes then are x equals 2 and x equals negative 1. So at positive 2, I'm going to draw this vertical line, and I always dot my vertical line. And at negative 1, I'm going to dot that vertical line as well. Okay. Fifth one, we're going to ask you about horizontal. Now on the quiz, I'm probably going to split this up A, B, C, D, things like that. The horizontal asymptote, in this case, the degree on the numerator is less than the degree of the denominator. So if you look back at your notes, if the degree is less on top than it is on bottom, then I have a horizontal asymptote at y equals 0. So what that means is I'm going to dot this in, and here's where our problems start happening. If you notice, we say we have this asymptote at 0, but I actually touch the x-axis. And I want to come back, and I love this question for this reason. This describes the end behavior, not what happens in the middle of a graph. And so what it says is in this middle of the graph, it's okay to touch the x-axis. What's not okay is as you look back here at the end behavior, out towards these ends, these are where you cannot touch the x-axis. And so keep in mind, the rest of this, what I would do is, it says plot at least 1 point between all of the vertical asymptotes. What I would do now is go to your calculator in order to help you plot points. And all I'm going to do is kind of put some general ones in for you, some ones that I know I found. And you get this graph in the middle, and then you get a graph that looks like this on either side. And so I'm just kind of quickly putting this in for you to save some time, but you will want to make sure you plot points. But the biggest idea here is this idea of a horizontal asymptote in this case. I know we touched the x-axis, but a horizontal asymptote talks about what happens out here at the ends, not what happens in the middle of a graph. So please keep that in mind as you go through. We have one more example, and it's this idea of a slant asymptote. When we said earlier, if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. However, there's this big but there. If the numerator is exactly 1 higher than the denominator, then you have what's called a slant asymptote. Okay? A slant asymptote can be found by taking the quotient, that means divide, of the numerator divided by the denominator. Okay? And I want you to look at this picture. If you graph this, then I think we'll start to see this idea of a slant asymptote. But here's what we notice. The degree in the numerator is 1 higher than the degree in the denominator. That means we have to find the slant asymptote. And on a quiz and a test, I'm not going to tell you if there is one or not. This is a rule that you have to remember. Okay? That's supposed to be a star. Okay, so here's what we're going to do. We're going to divide. And I'm going to take this division, and I'm going to take x minus 1, and I'm going to divide that into x squared plus 3x minus 2. And I know you're all thinking, yay, long division. Yes, it came back. It's why we spend so much time going through it. So x times what is x squared? We need 1 more x. X times x is x squared. X times -1 is a negative x. And then I subtract. These will cancel. 3x minus a negative x means add an x. You get 4x and drop down the 2. One more time because you can go. X times 4 is 4x. So 4 times x is 4x. 4 times -1 is -4. And I again subtract. My 4x's cancel. -2 plus 4 makes 2. What's great about this remainder, don't care about. You're looking for an equation of a slant asymptote, and all I care about is this quotient. So my slant asymptote is y equals x plus 4. What I would like you to do is plug this into your y equals as well as this. Plug them both into your y equals. And what you'll end up seeing graph-wise is you're going to get a function that looks something like this, and I can't guarantee my accuracy on this one, but it's going to give you this idea. Actually, I think it goes down here. It's this idea where you have this dotted slant asymptote at x plus 4, and you get these 2 branches. And what you have just found is this slant line here. Now again, my drawing's not to scale, but I want you to get the idea of what's going on. So this is section 2.6. Please, again, circle and star things you're not sure of, and we will look at them as we go through. Once we get in class tomorrow, you can ask any questions you need. So thanks for watching, and we'll look forward to seeing you in 2-7.